here I am, Tech. Where's the boss?
Right behind you, Duke. Why don't you give him a hand with those brake parts?
Here, Ed, let me take some of those. Want them up on the bench?
Yeah, Duke. These are the new 3-platform brakes I wanted to talk about.
These are new? Boy, they sure look the same.
Looks can be deceiving, Duke. While these parts are similar, don't you dare treat them the same. They're not interchangeable.
Tech's right. The dust shield, shoes, support assemblies, return springs, and wheel cylinders are different. The big basic change involves the dust shield and brake shoes. 3 platforms pressed in the shields, plus 3 loops formed on the sides of the shoes, guide the shoe and keep it in more accurate alignment. And besides this truer alignment, the loops and platforms provide better shoe dampening. Overall, the result is improved brake operation.
Sounds like a big improvement, Ed. But tell me, do I have to take a brake apart to see if it's the 3-platform setup?
You shouldn't have to, Duke, unless the back of the dust shield is too grimy. Look for the 6 platform depressions, 3 for each shoe. They have a waffle-like pattern.
Oh, I get it. Okay.
Now let me go over the changes in detail, Duke. Then you'll find it easier to identify the 3-platform brake. That dust shield just mentioned, for instance, has the 6 platforms. In addition, the holes for the 2 dampener coil spring rods are closer to the center of each shoe web. Now, here's a shoe from the former type brake. Notice the single, fairly large contact loop at the edge? Well, you see how the new shoe differs? It's got 3 contact loops, and each one is much shallower in design. The new contact loop outer edges are flush with the edge of the shoe table. Inner edges of the loops are formed to keep pressure from bending the loops inward.
Here's something else. The large hole you're used to seeing at the heel end of the web has been eliminated. That, of course, beefs up the shoe at that point.
I see. I'll keep those shoe differences in mind.
Attaboy, Duke. Now, there's more space between the plates of the support plate assembly. Actually, an extra 1/16 of an inch. That's to eliminate any plate-to-web interference. Inner and outer plates also are identical. The large ears on the inner plate of the former assembly have been eliminated. That's where the flat guide retainer springs were once assembled. The support plate assembly, in short, serves more as a carrier than as a guide.
I get the connection. The contact loops and platforms guide the shoe so well the support plate doesn't have to take care of that anymore.
That's the idea, Duke. Pure and simple. Opening up that space, though, called for a wider slot in the front wheel cylinder. It's now 7/16 of an inch instead of 3/8.
1/16 more, just like the plates, huh?
Right. And the front wheel cylinders have a new boot, see? There's a collar at the outer edge of the boot.
What's that collar supposed to do?
Well, it provides better sealing against water and road splash between the cylinder and its opening in the dust shield.
Well, that's good news. How about the rear cylinders?
Rear cylinders have a deeper machined surface on the bolting flange. There's also a spot of white paint near the casting number so you can tell the new rear cylinder. Return springs on both front and rear brakes are also different. They're assembled at an angle between the wide loop in the shoe and the spring link and have a load capacity that's 25% greater. 5 coil springs are used on all 12-inch brakes. 6 coil springs are used on all 11-inch brakes. Be sure you don't get them mixed.
And here's another point to remember. We've had 5 and 6 coil springs before, but they were lighter scale. So go by the part number. Then you'll be sure to use the right spring.
All right, I'll watch that.
Now, here's how to remove the new return spring when necessary, Duke. Put a large screwdriver between the web and spring at the shoe loop and lift up. To install the spring, first position the spring link properly in the support plate. Hook the spring into the link. Then, with a pointed drift, snap the spring loop in the shoe. Remember that the spring link hooks around a post in the support plate assembly and is held there by a dimple in the outer plate. If the link moves out of position, use a screwdriver against the link to bump it back into place.
Simple enough, Ed. Now, what else is different?
Why, new coil spring and rod-type retainers are used to hold the brake shoes firmly against the platforms. They replaced the flat spring-type retainers used on other brakes. The retainer assembly has outer and inner retainers, a spring, and a rod. It's used on front and rear brake assemblies on all models using the 3-platform brake.
Uh-huh. I get the picture. The head of the rod's against the dust shield extends through the shield and shoe web. 2 retainers and a spring are assembled on the rod and against the web to hold the shoe in place.
That's it, Duke. And besides holding the shoe, you get the benefit of some dampening to help eliminate vibration.
Yep, I can see how that would work all right. Now, where do we go from here?
Well, that about wraps up the various differences in design, Duke. Now let's talk about some service operations on the brake, starting with adjustment. When you get right down to adjustment, the basic procedure is a lot like the one you're familiar with. The 2 shoes of the front wheel brake, for example, and the forward shoe of the rear brake are self-energized when the car goes forward. As a result, you adjust those front shoes and the forward shoe of the rear brake in the same manner. The rear shoe of the rear brake you adjust differently. Remember which direction you turn the cams?
Why, sure. On front wheel brakes, you turn the adjusting cams in direction of forward wheel rotation while you turn the wheel forward.
That's right. And turn them to move the shoes against the drum until the wheel locks. Then scribe a mark on the dust shield at the leading edge of the wrench. Next, turn the cam back 1 hex, or 60 degrees, to free the wheel. Finish the adjustment by turning the cam 50 to 55 degrees in the direction of forward wheel rotation. That will bring the leading edge of the wrench within about a ½ inch of the mark you made on the dust shield. That keeps the spring link from loading the cam and causing a false adjustment.
Don't forget to spin the wheels to be sure the drums run free and the shoes don't drag.
I'll remember, Tech. Now I adjust the front shoe cam of the rear brake in the same way, right?
That you do, Duke. But when you adjust the rear shoe cam of the rear brake, you turn it in the direction of reverse wheel rotation as you turn the wheel.
Okay, Ed. And when I'm done, I'll turn the rear wheels both ways to make sure the shoes don't drag.
Attaboy, Duke. Now let's wait 5 seconds while somebody turns his record.
Well, I shouldn't have any trouble with platform brake adjustment, Ed. But how about disassembly or installation? Anything special?
No, Duke, just the usual amount of care to keep the lining clean. Whenever the shoes are removed, inspect the heel end of the web for signs of interference with the support plates. Any web that's flat within specifications should center itself between the support plates. Even a web slightly off-center will be okay as long as there's clearance between the web and the support plates.
No clearance there means the shoe is bent, I suppose.
Could be, Duke. You can use a surface plate to find out how flat the web is. Hold the heel end on the plate and swing the toe end across. A bent shoe can't be straightened, remember. A new one will have to be installed.
Tech's right, Duke. And keep in mind that the web should be centered on the shoe table with no more than a 1/32 inch variation on either side.
1/32, okay.
And be sure that only approved shoes are being used, my boy. Look for the letters DPCD stamped on the web.
Use nothing else but, hey?
Definitely, Duke. Anytime you find off-brand shoes on one of our cars, take them off. It's more than a matter of being too risky. It's downright dangerous.
Okay, Ed. I know what to do about off-brand shoes.
Good. Now, platform brakes normally won't need lubrication. But if you find it necessary, put a small amount of door ease stick lubricant on the platforms and at the heel and toe ends of the shoe.
It's better to use too little lubricant than too much, Duke. At high brake temperatures, any lube is apt to turn to liquid and contaminate the lining.
Yeah, I can see how that could happen. Okay.
Now, here's something else to watch, Duke. Platform flatness and height. It's got to be accurate. Unless they're right, there'll be brake noise, and a shoe might even get hung up. If you've got any doubts regarding platform flatness and height, let's say the car's been in an accident, or the dust shield was hit by the hoist, or bent by a floor jack, replace the dust shield.
Can you measure those platforms to be sure?
Yep, use this brake shoe gauge and a feeler. With the shield installed, all the platforms for one shoe should be in the same plane, within 10 thousandths. There shouldn't be more than 20 thousandths variation between the platforms for one shoe and those for the opposite shoe.
10 thousandths on one shoe's platforms, 20 thousandths between both sets of platforms. Okay, I'll keep it in mind.
Be sure the lining is ground flush with the edge of the shoe. Can't allow any overhang if that shoe is going to guide on the platforms.
Tech's right. But now let's look at the master cylinder. It's used on all cars without factory-installed power brakes, and it features a non-adjustable push rod. The master cylinder used with power brakes has an adjustable push rod. Notice that the master cylinder has a new piston. A rubber ring fits a groove in the forward end of the push rod and secures the rod in the piston. In addition, there's a new rubber boot and boot retainer that serves as a piston stop. It's these new features that help the master cylinder automatically maintain proper push rod free play. The piston stop does away with the need for any adjustment.
The brake pedal return spring has also been eliminated, and no pedal stop is needed.
Right, the pedal return travel is limited by the boot retainer. The pedal itself is returned by combined action of the piston return spring and pressure in the cylinder. You might think that the pedal returns too slowly, but the master cylinder piston returns as quickly and completely as it ever did.
I get it. But I'm wondering, if no adjustment's needed, all we have to do is see that the proper level of fluid is maintained, right?
Normally, yes, but there's a new disassembly procedure if you ever have to recondition this new master cylinder. The piston, push rod ring, and boot retainer are furnished as an assembly and are not to be taken apart. If you have to remove that assembly, just take out the two screws that hold the retainer to the master cylinder. If the piston has to be replaced, you'd install this complete repair package. It contains all internal parts needed for reconditioning the master cylinder. However, piston replacement is rarely necessary. Frequently, this partial repair package is all you need. It contains a boot, piston cups, washer valve assembly, and a seal. You follow me?
I read you loud and clear. What's next?
Proper front wheel bearing adjustment, Duke. It's done somewhat differently and is still mighty important to bearing life, steering control, and effective braking.
You're so right, Ed. Loose front wheel bearings can cause brake noise as well as pull. Bad lubrication practices can also stir up a hornet's nest.
Bad lubrication? You serious?
Tech's serious, all right. A lot of lubricants can't get along with each other. They cause a chemical reaction that can damage the bearings or turn into a sticky, gooey mess that doesn't lubricate. So when bearings need lubrication, always wash out the old lubricant first. Never add new to old lubricant. At the same time, install new dust seals. But now, getting back to bearing adjustment. You remember that tightening them to 90 inch-pounds torque has been recommended. But when the bearings are repacked, the new lubricant might keep them from seating properly during the tightening. As a result, some bearings have loosened up more than the specified 0 to 3 thousandths clearance after the car operated a while. So here's what you should now do. Tighten the adjusting nut to 180 inch-pounds as you rotate the wheel. Put the lock over the adjusting nut so the cotter pin hole lines up with one set of slots. Without removing the lock, back the nut off 1 1/2 slots. That positions the nut lock so a tang blocks the cotter pin hole. Remove the lock and reposition it so you can insert the cotter pin and secure the adjustment.
Very clear, Ed. I'll use the new specifications.
Good. When all specifications are maintained, brakes do their job well. It's only when something's out of adjustment that brakes might pull, dive, fade excessively, or cause noise. You know what we mean by brake pull?
I think so, Ed. Let's see. Isn't brake pull when the car shoots off to one side on brake application?
Yep, and it's usually due to a difference in braking effort between the linings on opposite wheels. A pull to the left, for example, may be a sign that something's wrong on the right, the opposite side. poor adjustment, or a lining condition like contamination by oil, grease, or other foreign matter. Besides that, there's low or uneven tire pressures, improper front suspension alignment, improper front wheel bearing adjustment. All can cause uneven braking that results in pull. Now, brake dive is just a heavy pull. Dive takes place shortly after brakes get hot, as they will after several hard brake applications. It's an early sign of lining fade.
Are you saying that correcting a fade condition will get rid of brake dive?
Why not, Duke? Fade is strictly a loss of friction due to heat. The hotter the linings get, the more friction ability they lose.
Actually, Duke, there's always some fade present. It's a natural characteristic of the mineral-type lining material that has to be used. You've certainly noticed that after a lot of sudden stops, made on a turnpike or going down a steep hill, it takes longer and longer to stop. That's why motorists are told to go slower, so braking will be more gradual. And that's why it pays to use a lower gear when descending steep grades and let the engine help with the braking. The brake lining we use is designed to give the best braking for average driving conditions. Bad fading shows up when non-approved lining gets on a car.
You just hit a nerve, Ed. Approved lining is a must. And always be sure that the correct shoe and lining combination are used.
Amen, Tech. Intermixing shoes or lining materials only invites trouble. On Imperials, use only new Chrysler Corporation manufactured shoe and lining assemblies.
Should new shoes be cam ground before I install them?
No, Duke, they're already ground. But you should hold them against the drum to make sure they're ground properly. There should be 0.004 clearance between the drum and the heel and toe ends of the shoe.
0.004. Okay, I'll watch that.
Fine. Now, that about covers what I had in mind on the new platform brakes. There's more service information, though, on power brake adjustment in this reference book.
Good news, Ed. I'll be sure to dig right into that.
Attaboy, Duke. Brake service is one place where we can't afford to slip up. Too much depends on it.